Did you ever wonder why sometimes when you're sitting in your house and all of a sudden a jet plane goes by or a helicopter flies over your house, or even when a heavy truck comes down your street and passes in front of your house, do things begin to shake and rattle and roll? Now why does that happen? Well, in order to understand why that happens, we have to go to the heart of the atom. Now, all atoms vibrate. By their very nature of existence, they vibrate. And they shake back and forth and up and down and oscillate in different ways. And each atom has its own unique vibration rate. And that vibration rate is the clue to what we're talking about when we talk about why things shake, rattle, and roll in your house. And this is a property called resonance. Now, really what resonance is a matching of frequencies one to the other. So, for example, all materials have vibrational rates. And these vibrational rates are controlled by the structure of the atomic structure that makes up the material that's in it. So, if the helicopter is flying by, and let's say, for example, it's producing a frequency of 512 cycles per second. That means it's spinning around 512 times every second. And as it's doing that, it's producing change in the air, and we're going to get air pressure vibrations, which will continue to fluctuate and move down throughout space. Now, if you happen to have, let's say, a dish in your house that happens to have the same structural phenomena in terms of its atomic frequency rate, then what's going to happen is these two rates begin to match each other. In other words, they sort of like communicate with one another, and they can talk to one another. So when that pressure wave goes by and it matches that rate in your plate or your glass or your dish or whatever else that it is, it's going to change and transfer its energy into the plate or the dish or the glass or whatever object to vibrate also. And those vibration rates that you experience, you hear as the rattles and the crackings and whatever else you hear. Now, I just said it was transferring energy from one place to another. I have another light box, which I'm going to place a short distance away from the first one, without physically contacting the second box. I'm going to cause it to begin to vibrate by a process known as forced vibrations. I've stopped the first box, and now you hear the oscillation in the second box. Listen again. I'm going to stop the second box just to prove that it is vibrating. Whenever an object vibrates in this manner by forced vibrations, and it's a multiple or the same frequency of the vibrating object, we refer to this concept as the property of resonance. Let's use this as an example. We've all been on a swing at some times in our life as a kid, and we know that we started out by sitting on the swing, and we started to pump. We started to pull on those strings, and we pumped with our knees, and we pulled ourselves forward, and the swing started to move back and forth. And if we were lucky enough to have a friend behind us, he would stand behind us and he would push. Didn't push with a lot of force, but he had to wait till you came to a certain position, and then he pushed again. And what did you feel? Well, what you experienced was you started to go slowly, and then every time he pushed you, you got more energy, and your swing of the amplitude of swing got greater, and you kept pushing at the right point, and what happened was eventually you got enough energy that you swung pretty high in that swing. Now the same thing happens when energy gets transferred. So if we could continue to push energy into a system at a controlled rate and a periodic rate, what would happen is we can keep boosting the energy into those molecules, and they vibrate. First they start out slowly, and then they vibrate rapidly. And this is known as
the process of amplification of the wave. Now, if we want to amplify waves, we can do this by, let's say for example, a perfect example of this is, you've heard about people who can break glass when they sing. Now how does that work? Well, it works in the same way. If you could get, let's say, an opera singer who can have a very high pitch and can maintain a force in their voice that will produce a pitch at the same frequency, let's say, as a champagne glass, and they allow their voice to go and just like the swing, keep putting energy into that pressure wave, that's going to be absorbed by the glass. And those little molecules in the glass are going to start to vibrate, and because they're going to be periodically put in, just like the swing, they're going to vibrate farther and farther and farther, and eventually they vibrate at such a rate and with such an amplitude that the structure of the glass can no longer hold itself together, and we have the shattering of the glass. Now there's a story that comes out of the Old Testament that talk about the walls of Jericho falling down. And according to the story, the Jewish people walked around the walls of Jericho for 7 days. And they were blowing horns and they walked in step. And what they were doing because of that was doing exactly what you did on the swing. Because they were walking in step, they were building up the pressure. And as they're doing this, the walls were absorbing that pressure. And supposedly, after 7 days, what happened, the pressure became so great and the buildup of energy became so great in the wall that the wall collapses. Another example of this is it's called forced vibrations. And if I were to take a tuning fork and then I took a guitar, I could bang the tuning fork. And let's say the tuning fork is tuned to a middle C of 256 cycles per second. And I take that tuning fork and I hit it and let it vibrate. And then I take the stem of the tuning fork and I put it on the guitar itself, on the body of the guitar. Now, of all the strings that are on the guitar, there's only one that's attuned to the tuning fork's frequency. And so by putting a piece of paper on that string, on the strings, you'll see that the only piece of paper that's going to move is the one that's in tuning with the tuning fork. So, another example of this is if you could sing close to a piano string and you were to sing a certain note, you could listen to that if you put your ear to the sounding board of the piano, and you will hear that string vibrating on the piano soundboard because you're now matching sounds. Actually, the principle of resonance is the reason why we can hear and tune in television and radio signals. What they do is that they take the waves that are coming from the studio or from the cable station that we have, and they're brought into our TVs and into our radios. And inside the radios, there's a circuitry that will take the wave that is tuned to that which carrier wave that came from the studio, filter out all the other stuff, and just allow that one particular frequency to get through. And that's how you tune a radio or tune a TV to a particular station. So what is resonance? Resonance is the ability of two substances or more to vibrate at the same rate. And for one substance to cause a second substance to vibrate at that rate, when it transfers its energy from one substance to another, that has that same vibrational rate. So when engineers look at the world around us and we build things, we have to worry about this concept of resonance because we want to be safe and we don't want our buildings and our bridges to collapse. And it's a common experience that we have all the time. So the next time that you listen to your house shake, rattle, and roll, you'll know it's only Mother Nature trying to share her frequencies with one substance and another.